Okay, so we have a few announcements before we start. It's going to be a little hard to see the projector, isn't it? It's nice to see the sun out, but there's some downsides. So the first big one, the team project report checkpoint is today. So what this means is after this checkpoint, over the next week, by Friday is the deadline I gave the TAs. By Friday, the TAs are going to give you feedback on your reports for your team project. So get those reports as much as you can by today. There's no strict grading requirement for this checkpoint. It's strictly to give you feedback on your reports. So the whole entire project is due on that last day of class. So at that point, whatever you have for your project and your reports, that's what's going to be graded. And if you have, even if you have a fully complete project, everything's good with your project, you meet all the criteria and everything, but your reports are lacking, you can still get a very bad grade all the way down to potentially a 0 if your reports are just absolute garbage. So, and since reports, I think I'm the only one who has this reports requirement. It's probably something you haven't seen before. I want to make sure that you have a chance to get feedback on your reports before you hit that deadline. So that's the idea of the report feedback. It is strictly optional, but oh my goodness, it's a huge risk if you don't have at least one report done by this checkpoint, by tonight. So take advantage of this round of feedback, get your feedback, and then we want to get the feedback to you before we go into break. So you have these last 3 weeks. You don't have to work over break, of course. So last 2 weeks, but you also have a break to think about it, think about your report feedback to know what you have to do with those. So I would get at least one report, if it were me, at least one report completely done the way that I think reports should be done. So you can get the feedback on either, yes, this is what we expect for reports, and this report is solid, do this with your other libraries and you're good to go, or no, this isn't quite what we expect for reports, this is what you have to change, etc. The TA who gives you your feedback for the checkpoint is going to be the same TA who grades your final project. So whatever feedback they give you, like they'll look at your reports again, make sure that you incorporated their feedback, and then they'll grade you by those same criteria. Just in case 2 TAs happen to look at the reports just a little bit different, you don't have to worry about a different TA grading your project, then gave you the feedback. Whatever that feedback says, that's what you can take as effectively the truth. Like if you incorporate that feedback, you're good to go. Now, if your reports are just very haphazardly put together by the checkpoint and the feedback is, this isn't what reports are, you might get very vague feedback if you don't have good reports. And then you could say, well, I made better reports for the deadline, you might be able to incorporate the feedback and still think you incorporated all the feedback, but still not get the full credit here. So just a heads up on everything. I just want to explain the structure of how this is happening, the criteria for that. For the logistics of this, aside from doing the reports, there's nothing that you have to do that hasn't been already discussed, that's not in the documentation. The TAs are going to go into your repos. They're going to look for that directory named reports that's in the root of your repository. They're going to look for that directory. They're going to go in there, look at your reports, and give you feedback based on what's there. So the reports, a quick reminder on those. Please use the report template. I think this is officially required. I forget if I didn't put that in any documentation, that's not required. But I think I did add to the project. You know what? I might as well just check. I'm pretty sure I added the wording that's required. Create a directory named reports. It contains all your reports as PDFs. There it is. You must use the report template. So it is required. So you must use, and by the way, even when I make a decision, I'm like, this is required, but I don't communicate that well, I won't stick to that. Whatever's communicated to you, that's the decision I'll stick with. That's the only reason I was checking that documentation. I want this to be required. I had to make sure that I did communicate that to you, or else I'm not going to make it required. So but it should be required, and it is because I have the communication there. So the open source repositories, or open source reports, this little table, make sure you fill this out. The licenses, there's not too much to do here, but if your library has some strange license, make sure you read into what that license means to you. What does it restrict? What does it allow? Is it a license that lets you do whatever you want with that code? Or is it a license that restricts what you can do? Maybe you can use it, it's open source, and you can use it for whatever you want as long as you don't make money. There are licenses like that. Maybe you can use it as is, but you can't modify it. Maybe you can use it, but you have to inherit the copyright, which is a copyleft license, what we call. So if you use that library in your project also has to be open source with that same license. That's a copyleft license. So what restrictions are there with the license for this library? If you use even one license, one library with a copyleft license, you have to open source your material. You have to open source that and let everybody use that content. So are you using one of those? What are the implications of using that library? Make sure you look through those. This auditing your libraries, this is a big deal in industry because you use one of those libraries, one copyleft library, and you have to open source your code. In industry, that's usually a bad thing. You wouldn't use that library. So tell me about the license. There are a handful of licenses that are common out there. So this will involve looking at a few of the common libraries, or a few of the common licenses, and then all the libraries you use probably have one of those licenses. So look into those, and what are those restrictions is the big one we're looking at. And of course, the TAs are going to be familiar with all those licenses. So if you say GNU license, and you don't have the proper restrictions, they got to let you know about that. But that's pretty straightforward. Read up on the license and figure out what that license means. And then for each piece of functionality that you use from this library, so this next section, the purpose and magic, this is repeated multiple times. So if you're pulling in one library, but you're pulling it in for multiple things, fill out this section for each piece of functionality. So for example, your top level framework that you're pulling in, assuming you are, and of course, there is always the option of treating the project like a homework and not using any libraries that are not allowed on homeworks, and then not writing reports. So that's up to your team. Make that decision and decide how you want to approach this. Reports, if you do pull in libraries, reports might even be at least equal, but maybe more work than actually learning how to use that library. So just keep that in mind. I strongly recommend pulling in libraries and doing the reports because you'll learn a lot more. And those are, in industry, you're going to use libraries. In industry, you're never going to start with a TCP socket. So getting more practice starting with a TCP socket doesn't help you out there in the real world. You already got what you need to get out of that on the homework assignments. For the project, it's your opportunity to learn something else, something that you're actually going to use out there. I do recommend using that. But I leave that option on the table. Some teams take it. Don't use any libraries that aren't allowed on the homeworks, and then don't write reports. Just letting you know that option's there. When you pull in a library, if you do, for each piece of functionality. So for example, you pull in your framework. You're pulling that framework in for at least two different things: handling your TCP connections and communicating over that TCP socket, and parsing your HTTP requests, especially the headers, the requests, getting the path, extracting the path, and things like that. That's at least two features. So those two features would be separate sections. Purpose, I'm using this framework to communicate over the TCP socket. And then next, purpose, I'm using this library to parse my HTTP requests. And you can probably lump requests and responses into one section. It's up to you exactly how you want to divide it. But I would separate those into at least two, probably one for requests and responses. Parsing requests and assembling responses. So the first part of this, purpose, why did you pull in this library? Like what is the functionality that you're getting out for this piece of functionality? Why did you pull in this library? I've had students ask me, I don't know what to put in this section before. This is just the reason, if you're importing a library, there has to be some reason why you decided to import that library. Just tell me what that reason is. We're not getting too crazy with this one. Just tell me your team sat down and made a decision. We're going to say import whatever. Why? Why'd you make that decision? And it's probably, to handle our TCP connections, fine example. To parse our headers so we don't have to do that, fine example. But just give us a quick description. Why did you pull in this library? And then magic. This is where you're going to spend most of your time. I gave the demo earlier in the semester. I'm not going to go through another demo today. But I just want to remind everyone, just because the checkpoint is here, the magic is where you're going to spend most of your time. This is where you're going into the code of these libraries. They're open source. They're open source reports. It means you have access to the source, right? I want you to get into that source, into that code, and show me where the magic's happening. You pull in these libraries, they seem to just work by magic. You tell it to do something and it just does it. How does it actually do it? Go into the code and tell me how it actually does it. For the magic, I want to see the whole chain of custody, is that the right word? But the whole path from your code, your starting point should be your code. I called this method. I created this object. Whatever you did to interact with this library. And then I want to show each step along the way through that library and through other libraries, other dependencies, and eventually getting to the ending point of code that looks like your homework code. So for example, if you're pulling in a WebSocket library and you say, we use Socket.io to handle WebSocket connections and WebSocket frames potentially as two separate sections. If you want to separate those into two separate or leave them one, I'll leave that up to you. But we pulled this in to handle our WebSocket connections. The very starting point would be, here's where we actually create the WebSocket server. And by the time you follow all the paths, all the steps down to the bottom, at the bottom, I want to see that the two things I mostly look for WebSockets, and the way I've coached the TAs that they'll look for as well. I want to see that globally unique ID. I better see that somewhere in the code, right? If you're making a WebSocket connection, I got to see that ID. Like that string is part of the protocol. It's got to be in your report. You got to show me where is the code that's actually taking that WebSocket key and generating the accept header to send back to the user. I got to see that SHA and the base 64. And for frames, I want to see some bit manipulation. Where's the code that's actually parsing these frames and doing the bitwise manipulation, pulling out the mask bit and everything, pulling out the payload length? Like, where is that code in the library? So from your call, travel through these libraries and get to the code that looks like your homework code that does the stuff that you did on the homework. And we saw from the example last time in class, like that chain is going to go through a lot of libraries. Sometimes the links are very obscured. So we're not going to be too picky on the exact traces of the code. Like, it doesn't have to look like a stack trace. It's great if it does, but it doesn't have to. It's very hard. You saw in my demo earlier in the semester that it's hard to find all of the links between these. Mostly because the libraries are going to work through interfaces. You're going to get to a point where the code uses an interface. It takes you to that interface, but it's not going to take you to the implementation, the specific implementation of that interface that's used while you're running your server. That's a bit harder to find. So if you're like, this uses this interface, and over here I found an implementation of this interface, and I actually even did that in lecture. Here I found an implementation of this interface. I'm not sure if this is the exact one that's being used, but this is an option. This is a way that it can do it. Not necessarily sure if it's the way that it's happening in our app. That's fine. We can be a little fuzzy about that. We're not going to be too picky about that. But we do need to see the end of the chain, the code that looks like the homework code. So if you're working on those reports still today to get those ready for the checkpoint, that's the criteria. Just a reminder, those are the criteria. That's what we're looking for. If you didn't get to that code that looks like homework code, because it has to be in that library somewhere. Like these libraries, the whole point of this, libraries don't work by magic. At some level, they have to have code that looks like your homework code. They have to. HTTP is a standard. WebSockets is a standard. They're standardized. They're published protocols. And we implemented those protocols. The library has to do that same thing. They have to be looking for /r/ns to parse headers. They have to be looking for the colons. They have to be looking for the path following that exact format. There's going to be code that looks like your homework code. And truly savvy, I always realize there's a little bit of a loophole in this course. Truly savvy students would do the reports way early in the semester and then use that code for reference. Look at that, understand how it works, and then not copy it, but use that to help them write the homework. Because all these open source libraries have solutions to the homework in them. They have to. How else do they work? They have to. They're such mature frameworks, they're such mature pieces of software that have been built up for so many years that it's a bit harder to see that. And that's the whole point of these reports. I want you to see that this is just code that you can write, that you have written for your homeworks. You know, Django isn't anything magical. It's just somebody sat down, a group of engineers sat down, effectively did the homeworks for this class, and then just kept building that out and building more and more structure and adding more and more features for many, many years. That's what a web framework is. You've built a web framework for this course. Not necessarily a versatile one, like you can't import that and then use it for different functionality because everything's hard-coded for the objectives, but you effectively did build a web framework. So that's the whole idea of the reports. It's getting you to see that. So I want to make sure in this magic section, you do get to that point where you see the homework style of code, the stuff that you did in this class for the homeworks. All right, any questions on the reports? So today's a big day for some of you. It's the last day to resign, just in case somebody wasn't aware of that. Given that, I talked to the TAs, worked with them and everything. They got their hustle on, and homework 3 grades are released. I released them right before lecture. So you can check out your homework 3 grades if that factors into your decisions. You know, I wanted to make sure that's out there. The TAs were able to rearrange their schedules and get that out. So homework 3 grades are out. To be honest, looking at the course as a whole, they don't look super great. So I don't know what decisions you're going to make based on that, but you know, we'll see how it goes. Just a reminder on the grading, if you are thinking about resigning, as long as you have ones, like ones don't hurt you too much with the grading structure. It's those zeros that really hurt you. You know, every homework has the same grading structure. So just a reminder, because I hear a lot throughout this class. I think it's mostly because Autolab automatically adds up your scores for the objectives, and that's the score display, some score out of 15, which is really misleading because the objective scores are nonlinear. A 3, 2, or 1, even a 1 is significantly better than a 0. It's the zeros that hurt you. I said this early in the semester, but a quick reminder for the resignation deadline. It's the zeros that really hurt you. That's my way of saying at least try everything. At least try. If you try, we're going to try to justify giving you that 1 instead of the 0. And even if you get all 1s on every objective, you can get a 60 in the course. But if you get some mix of 1s, 2s, and 3s, but then a couple of zeros in there, that really drops your score down. It's intentional, it's by design. It's because I want you to at least get your hands on every topic of the course, every objective. This is my way of communicating that. That said, when we get to course evals, which actually just opened up, I'll start advertising my bribe for course evals. I'm going to drop at least 1 objective. So the way you can look at your score for this class is each homework has 5 objectives. So there are 20 total objectives for your homework grade, which are effectively averaged together. Like you can compute your individual homework grades and then average those, or just look at it as 20 objectives and just average all of your objective grades together, divide by 20, and then add them up, and then convert them, add them up, divide by 20, and get your overall homework grade. So there's 2 different ways of computing that. I'm going to use both ways. Right now, with what I've said so far, they'll come up with the same number, of course. But I'm going to use both ways of computing and then take the one that helps you the most. The reason they could be different is because I'm going to drop objective grades. So if I drop like 3, your lowest 3 objectives from a single homework, that's going to come up with different math. If I do the homework averages, actually, does it? It does, right? I'm not going crazy. Anyway, well, I'll find out. If they're all identical, I'm still going to take the max. It'll be the same thing. But I'm going to drop at least 1 objective grade. Based on the course evals, I'm sure you've seen this multiple times by now. You made it this far. But I'm going to have my course eval bribe. If the percentage of the response rate is, hits certain criteria, I'm going to drop more objectives. I anticipate that I'll probably end up dropping 3. I just historically speaking, what the response rate gets to with certain bribes and stuff. And then I'll have like a stretch goal of 4. If we get like 95, I don't know what the cutoffs are going to be. But I'll have some stretch goal of 4. But I'll have it reasonable. Probably 80% response rate will be 3 drops is probably what I'll end up doing. And historically speaking, that usually gets hit. Like an 80% with a decent bribe, we can get up there. So if that factors into your decision of resignation, I just want all that out there too. Or anyone who's thinking about resigning probably isn't even here, and they'll watch this video too late or not at all. So maybe I'm just wasting all our time. So does anybody have questions on that? Questions on how the course is going to be graded, especially if it matters to your decision of whether to resign or not? So I want to give you all the opportunities you can so I don't get emails after resignation that said, I would have resigned if I knew that. I just don't want those emails. I've gotten those in the past. It's always frustrating because it's like, fuck, I got to fail you now. You could have cut loose with an R. I don't want to, I'm not after your GPAs at all. I just want y'all to learn. I don't care about your GPA. I don't care about your GPA in the way that I want to help you not hurt your GPA. So any questions on how things are graded? Okay. In the project, I haven't really talked about how the project is graded, but as long as you do your reports, the project, actually there's a little bit more I want to talk about with the project. As long as you do your reports, like I haven't seen teams not able to complete the project. You pull into a framework, it does all the heavy lifting for you. It's not too hard. It does take work to do the coding, don't get me wrong. But it's not too hard to get all the features working. It's the reports where teams lose points. The reports, I do have a list here if you're wondering if a report's allowed, or if a library is allowed with or without a report. These libraries are all allowed on your homework and do not require reports. It's like jQuery, Bootstrap, Redis, and Redis, which is used inside Django. If you're using Django, you're using Redis. I don't need a report for Redis. It's effectively another database. I don't need anything for that. And then explicitly, some that are requiring templates. If you use any of these, you do need reports, including Django channels, which uses Redis. I don't need anything for Redis, but I do need something for channels, for example. So, and if anything's not on this list, ask me. I'll make a decision. I'll give you an answer. Then I'll add it to this list in either the accepted or requires a report or not. And typically, if it does something for you that we've done in a homework, that's my general criteria, then it requires a report. So for example, front-end frameworks, we did HTML templating in this course. You had to do that for all the homework starting with 2. If you're pulling in something to do that templating for you, you need a report for it. Because it's effectively removing the need for templates, for you to do the templates. Front-end templates, if you go to some website and it's like, here's all these free front-end templates, and you just grab one and use that for your front-end, I'm going to need, I'll allow that. I used to just not allow it. I'll allow that, but you need a report for it, specifically because these often come with they come with terms and conditions or licenses, full-out licenses. So the licensing section is the big deal with this. The fact that you took that free template, what are you bound to now? And sometimes it's as simple as leaving the credit of the original author on your webpage, clearly displayed. But sometimes it's more than that. So you can use those templates, but let me know what you agreed to with that creator to be able to use their template. What was I getting? Where are the requirements? There. So the requirements, there are 5 requirements. And I have my example app. We talked about this early in the semester. If you just want to get through the project, just build the example app. I'm not thrilled about it, but this is the easiest way to get through the project. I'm just going to advertise that because when I don't do this, I always have a million questions like, can I get away with this? Can I get away with that? What's the bare minimum I have to do? Here's the bare minimum. Don't ask me questions about it. This is the bare minimum you have to do. If you just want to get through the project, just build that app. But in how you're graded is through these 5 requirements. There are 5 requirements, and they're all weighted equally. So each one is 20% of your project grade. So if you have all 5 requirements, you get 100%. If you have 4 of the requirements and with reports and everything's working great, 80%. Simple enough. If you are lacking in reports, I say up to a 0 in the entire project if you don't have solid reports, but the reports are going to be associated with the requirements. So one of the requirements is adding WebSockets, live interactions through WebSockets. If you have all 5 requirements done and everything's great, but your WebSocket report is really weak and just doesn't do what it's supposed to do, doesn't give the information that it has to have, you'll get a 0 for this objective, and then you'll get an 80 on the project still. So the reports are going to be linked to objectives, the objectives that you have, that you need that report to be able to complete. If there's a problem with your web framework report, well, it's going to affect all 5 objectives. Like you never explain how TCP connections are made. That's going to affect all 5 objectives, and that could be a 0 on the entire project. You don't even have a report for your framework. That's like the most important report is the framework one. Not just because of your grade, but because that's the one doing most of the heavy lifting. It's doing like most of the homeworks for you, most of the homework objectives. All right, I think that's all I want to say for announcements, grading in the rest of the semester, how the rest of the semester is going. So no questions? Anybody got a question? I have the lecture channel open too, if you want to ask questions there. You're allowed to use SQLite. Do I? Ooh. So this is another one of those questions. I have to check my documentation. I want to not allow SQLite, but if I didn't mention it specifically, yeah. So you have to use Docker Compose. At a minimum, you have to have a container running your database and a container running your app. So good, I do have this in the documentation. So my documentation is matching the spirit of what I want to do. And another container running your database. So technically, you can use SQLite, but it's got to be running in a separate Docker container, and they have to communicate. Well, your app has to communicate with that database through Docker Compose. So technically, you could run a container using SQLite, but you're not using what I want to avoid. You're not using SQLite to avoid the need to connect to a database. The SQLite just simplifies everything with your database. And it's also something you're not going to use in industry. You're not going to use SQLite unless you're doing mobile app development. You're not going to use SQLite. If you have, if any company out there, if you go out there and say, Jesse lied to me, we're using SQLite on our server-side app for this company with live users, let me know, because I don't know. I probably won't do anything, but I'll be upset with that company. I don't know. You shouldn't be using SQLite for production with live users. It's not made for that. It's made to be a lightweight database for mostly prototyping or to run on embedded devices. That's why it's used in phone apps, because you're not going to run MySQL Server on here. You're going to have a really lightweight database when resources are restricted. But you lose performance. You're not going to have the performance of a full server. So like it or not, at some point, you're going to have to connect to a database server in this industry. You stick with this industry, get that first full-time job. You'll be connecting to a remote database. It's just something you got to, I know it adds more complexity to talking to your database, but it's just something you're going to have to learn. Yeah, you're going to have to do in this industry. All right, so, oh my goodness, I didn't even look at the time. I spent way too much time talking about all that. Hopefully that was useful information, but let's get into some content. So last time we were talking about salting. This is mainly to prevent rainbow tables. There are other reasons for this, one that I don't mention too often, but if you don't salt, an attacker can potentially attack all of the hashed passwords simultaneously. So if you grab a database You look at everyone's hashes, and then you say, I'm going to guess the password, the literal string password. Hash it, and then check if it matches anybody's hashed password. And then take your next guess, password with an at instead of an a, check if that matches anybody's password, and you're effectively attacking every single user simultaneously. Salting also prevents that. You have to pick a specific user and attack that specific user because nobody else has that user's salt. So you can only attack one user at a time, and the rainbow tables are useless. So salting, a few benefits, a few big benefits that it has. So our procedure now, and I strongly recommend pulling in bcrypt for this. This is allowed on your homeworks. There's no reports required for your project. Strongly recommend just use bcrypt. It does all this stuff for you, and I'll show you a quick demo after this. It's super easy to use, and it does all the heavy lifting. So bcrypt, for tutorials, just bcrypt, language of choice. You'll have all kinds of tutorials to help you use it. It's very standard these days, bcrypt is. So your procedure here for registration, user gives you a username and password. You're going to take that password, generate a random salt for it, append the salt, hash the salted password, and then store both the salt and the hash along with the username in your database. That's what you want to store. Having both title is authentication. And then for authentication, somebody comes to you with the username and password, says, I want to log in. You're going to take their username, look up the database, go to your database and say, what's the salt and hash for this username? You're going to get that salt and hash, take the salt, append it to the password they just gave you, hash it, and check if that hash matches the stored hash. If it does, they're logged in, they're authenticated. If it doesn't, they're not authenticated. And it's a failed login attempt. In the code, here's an app where I do use bcrypt. I'll show you all the details. There's quite a bit of stuff going on here. But I'm taking it. Oh, frig, that's really hard to see, isn't it? I can't turn these lights down anymore. Maybe if I highlight. So when we want to hash a password, I got to the point where I have a password that I want to store in a database. I'm going to use bcrypt, hash password. There are three methods that you want to use from bcrypt. I'm going to use first, technically executed first, generate salt. I'm going to say, hey, bcrypt, give me a random salt. It's just going to give me a random array of bytes that it generates. And then hash this password with this salt. Bcrypt.hash password, which if we go into the library, takes the password in bytes and the salt in bytes. When bcrypt generates the salt, it's going to give it to you as bytes. And when you call this, you have to encode your password. It's not going to take ASCII or UTF-8 or anything. You have to encode your password into bytes, which you're all pros at that by now. You have to encode your password as bytes, and then it'll spit out the bytes of the password to store. And that's what I want to store in my database. So where I call this, I'm going to add that into my database. I'm using MongoDB here. I'm going to set my password to that hashed password. Now somebody gives me a password, a username and password, and I need to authenticate that user. I'm going to get my account, my get user just pulls from the database, gets all the information for this user, including their hashed password, salted and hashed password. I'm going to get the password from that user and bcrypt.check password. This does a lot of the heavy lifting again. I'm going to give it the bytes of my password and whatever bytes bcrypt gave me when I hashed this password. Now, when bcrypt hashes this password, the bytes that it returns isn't just the hash, but it's the hash and the salt, all in one array of bytes. So there's only one value that you have to store in the database. Just whatever hash password spits out, it's going to be the salt in plain text and the hashed password in a string that's formatted, or not a string, but in an array of bytes that's formatted in a way that the bcrypt library understands. Bcrypt library, when you give it that stored hash again, and the bytes of the password, the plain text password, so we're not doing any salting, hashing ourselves, we're going to let the library do all that for us. Give that password that the user gave us and the stored value. It's going to read that stored value, read the bytes, extract the salt, append the salt, hash, and then compare the hashes. It's doing all that inside this method call. So it's doing a lot of the work for us, just 3 calls: gen salt, hash password, check password. Those are the 3 methods that we want, and then whatever hash password spits out, that's what we're storing in our database as the password. So the method names might be a little different in each language, little logistical differences in each language, but this is still going to be the same procedure. No matter what language you're using, pull in bcrypt, call those 3 methods in this way, you'll be good to go on authentication. Once you do authenticate, and this I can make bigger so we can actually see it. Once we do authenticate, move my window back. Can't type a password under pressure. Okay. Now once we do authenticate, I want to show you it's still kind of hard to see, isn't it? Now, once we are authenticated, the password's hashed and everything, we're going to get to the point where we're inserting in the database. And I want to show you, just for an app that's out there, I want to show you what the stored passwords are going to look like in the database. So I want to check let's get my database names. Show DBs, use education, right? Show collections, DB, and this is where I got to be very careful. db.users.find username Hartloff. Pretty. Okay. I have to be very careful there because I don't want to leak anybody's hashed password. Then you might throw in somebody could throw an attack at it and potentially recover somebody's password. So I got to make sure I'm only showing my own data. And if we go into this, where I store the password, this is what's coming out of bcrypt. I'm going to get a string that looks like this. If you're using bcrypt and you're looking at things that look like this in your database, you're doing the right thing, most likely anyway. So this is encrypted, or not encrypted, hashed. This is the salt and the hash that I have for my password. So if you want to try to break my password, go for it. It's always going to start with something that looks like this: $2A, $10, $L. That header is always going to be similar. That's the header saying this is how many bytes for the salt, this is how many bytes for the hash. Anything that it needs to know, what hashing algorithm is used. Anything bcrypt needs to know, effectively the headers. Anything bcrypt needs to know to be able to parse this data. Then it'll extract the salt out of that, do its thing, and figure out what to do with this. Bcrypt will be able to do all that. So that's what they're going to look like in the database. That's a salted, hashed password. All right. We got a few slides on tokens, which is why I knew I could spend so much time talking about other stuff today. But tokens. So once you are authenticated, we registered, a user registered, they authenticate, they click the login, they enter their username and password, and Bcrypt says they're good to go. Oh, and check password returns a Boolean, by the way. So I'm not 100% on that. I guess we can check in 1 second. Oh, yep, Boolean. Returns a Boolean. It's just a yes or no, were they authenticated or were they not? Oh, come on, why? Oh, because I already have it open. So tokens are going to prevent, I've said this many times already, but they're going to prevent the need for our users, to enter their username and password every single time they do literally anything or load new content or anything. That'd be a pain. So when they authenticate, when they log in, we're going to generate a random token with enough entropy that an attacker can't brute force a token. They shouldn't be able to brute force any token. If they come up with a billion random guesses for tokens, none of them should match any tokens of any legitimate user. So we need a lot of entropy here. So at least hit our magic number, 2 to the 80 possible tokens. We got 80 bits of entropy. And we're at a point where the attacker's not going to be able to guess that. And hopefully by then our DOS detection is going to say, hey, something's up. Let's deny requests from this IP address at some point. Once you see that token, associate that, insert this token into the database with that username. That's what I mean by associate the token with the user. And then set it as a cookie. And whenever you see that token again, you're going to treat that person as that user. The entropy is high enough on these tokens that you're going to assume that nobody can guess them by brute force. So you see that token again, you say, well, there's no way you would have that token unless I actually issued it, because it's so random. There's no way anybody else would have that token. So you're going to respect that token and say, if I see a cookie with that token, I'm going to treat you as the user associated with that token. These tokens need to be hashed. This is part of your homework 4. When you store these tokens, make sure you hash them. There's no need to salt them. You can salt them if you want, if you just want to use the same code you use for passwords. Salt's not going to hurt anything, but you do need to hash them. These are as sensitive as passwords. If somebody gets that database full of authentication tokens, they can just take whatever token they want and become whatever user they want without having to recover somebody's password. So you need to hash these. Once they're hashed, even without a salt, there's enough entropy in, they are effectively very long random passwords. There's enough entropy there that we don't need the salt. We don't need that extra protection because we're not relying on users to generate strong tokens. We're generating strong tokens, and we're using code to do that, to generate tokens as long as we want. We can generate tokens of length 5,000 if we want. We can generate really long tokens and get hundreds of bits of entropy. We can get whatever we want out of these. So no need to salt, but we do need to store hashes. They're not going to be able to brute force that hash. There's no dictionary attack for that. There's no rainbow table attack for that. I guess technically they could rainbow table. So if you want to salt and prevent that. But the entropy is so high, the rainbow table would have to be so large that probably wouldn't have enough storage on the planet to have an effective rainbow table. I already said this a few times. I don't want to go over that again. So I want to get to my demo. But if the tokens, you get a request, look for the cookie with the token, look that up in your database that's associated with a user, treat them as that user. If anything goes wrong in that process, there's no token, or the token is not in your database, an invalid token, don't treat them as anybody, don't treat them as authenticated. So they'll be like, well, if they have this token, if they have this cookie set, they are authenticated. I don't know who they are, but they're authenticated. No, don't do that. If it's not a token that you issued, it's not a legitimate user. And for the homework, give them the 4-3 forbidden. So let's finally get to why I have Congregate open in a tab. So here's Congregate, which kind of took a big hit once Flash was no longer a thing. But I haven't been here in so long, but I see they do still have games. So I'm logged in right now. If I refresh, I don't have to enter my password again. I'm logged in. I can do what I want on this app. And those requests are going to be treated as requests from me. I have another browser where I'm not logged in. No login. If I refresh, I'm still not logged in. Let me accept cookies, since that's the whole point of what we're doing. Not logged in. It's asking me to log in. It's not treating me as any particular user. And if we go into the console for both of these, come on, Firefox. Storage. I was on the wrong tab. Sorry, Firefox. So if I go to this tab, I can see all the cookies that I have set. Modern sites use a lot of cookies. And I can see even some third-party cookies. Google has their fingers in here. Google's tracking me when I'm going to congregate. No surprise there. You'll see Amazon, Facebook. You'll see the big companies in a lot of sites that you go to. They got their cookies. They got their hands in everything, checking out what you do. So they can give you ads, basically. And I can see all the congregate cookies here. I have a few different cookies. I can't resize anything. I have a handful of cookies. And most of these cookies are going to be long random values because they have long random tokens that they're generating with enough entropy that they can't be guessed. And you can see most sites use tokens that are extremely long, extremely high entropy. They will not be guessed. If I go over here and take a look at my cookies over here, I have a lot of the same looking cookies. I'm going to have a couple of important ones that I want to look at. My congregate session. This is a session cookie, which is going to track me as I navigate the site. This cookie is set over here where I'm not logged in as well. Congregate session. It's hard to resize everything when I'm zoomed in so far. And I can double click this cookie and actually replace it. So I'm going to take my session cookie and I'm just going to paste it right here from the other one. There's one cookie that appears over here that's not over here, my Kong sec. So let me grab this cookie. It's going to be another random long string. And this is my actual authentication cookie. So I don't have an authentication token over here because I'm not logged in. Well, why don't we add one? So I'm going to add a new cookie. Copy. Paste. Refresh. And the server is going to treat me as me now. I didn't hack any passwords. I didn't steal my own password. I didn't log in. All I did was set 2 cookies. And I tried it. It doesn't work with just the set cookie. You have to have they're checking that matches the session ID, the session cookie. But all I did was change those 2 cookies. And now I'm logged in. I'm authenticated because I said, oh, this cookie matches what we have in our database. You must be logged in. We must have authenticated you. Because there's no way you can guess that cookie. You must be the legitimate owner of that cookie. So if somebody can steal your cookies like that, they can be you. They can log in as you. And the servers are rightfully going to just treat the attacker as you without having to know your password. Yes?
This is a really dumb question, but for hosting the session cookies on the server side, would it make sense to have a set timer for when they self-destruct? I'm assuming
yeah.
an issue if there's just a bunch of thousands of dead.
Yeah, if they're supposed to expire, if you set the expiration date, because I can just remove or change these expiration dates and have a cookie last longer. So it would make sense to have them expire on the server side too, if that's the feature you want. A lot of sites want these tokens to last forever, because, I don't know, I've had sites where I got logged out after a while, and then I would just stop using the site. I think a lot of users, they would lose a lot of users like that. There are some sites where I've logged in, and once in just years and years, I'm logged in like forever. So I think most apps don't want to do that.
Also, they have high entropy.
Yeah, they have high entropy, but if you steal a token like this, then then they can. But that's the only way. You're not going to guess these, but you can't steal them. It doesn't matter how much entropy there is if you're literally stealing these things. With that, we're 2 minutes over. We gotta go. 3 minutes. Have a great weekend. See everyone Monday.